Alright, the last one in this section, again, looks very complicated, which is why I wanted to go ahead and do it. But remember, you just have to keep in mind your rules for solving. Then we're solving an inequality here this time. But remember, our rules are the same as they are for equations, except we have the one additional rule, and that is if you multiply or divide by a negative, you have to flip the symbol over. So we're going to watch for that. Otherwise, it's doing what we know how to do already. So whenever we look at this, the first thing that we should see is that we have to do some distribution here because we have some parentheses. So 4 times 3x would be 12x, and then 4 times negative 1 would be minus 4. Now we also have to do some distribution here. So that would be a negative 5x and a negative 20 greater than or equal to, here we have a lot of stuff going on, don't we? Technically we have to work inside out. So technically we have to distribute that negative before we can do anything else. So I'm going to rewrite everything. It's 3 times 2. This would be minus x minus 3 and then minus 6x. Now, here again, technically we have to do what's inside the parentheses first. So even if you had to rewrite everything else, that's okay if you just need to do one step at a time. So inside the parentheses now, that would be a negative x and a negative 1 and then minus 6x. Now, before we move with our next step, we have to finish doing the distribution first. So if we finish doing our distribution, now we have 12x minus 4 minus 5x minus 20 greater than or equal to negative 3x minus 3 minus 6x. Now that we're done with our distribution, we can start in with the combine like terms step. So on the left hand side we've got a 12x minus a 5x, which would be 7x, and a negative 4 and a negative 20 would be a negative 24, greater than or equal to. Over here on the right hand side, kind of forgot my directions there, negative 3x minus 6x would make that a negative 9x and then a negative 3. And now we can start in with our addition property step. So if I move the negative 9x by doing the opposite, I add 9x to both sides. Now we have 16x minus 24 greater than or equal to negative 3. Notice I've been continuing to keep that symbol the same direction because we've not multiplied or divided by a negative anywhere. Now we need to use the addition property to move this negative 24 by doing the opposite, which would be to add 24 to both sides. So now we have 16x greater than or equal to 21. Now we can use that multiplication property to do the opposite of the multiply by 16, which would be to divide both sides by 16. Now we have x is greater than or equal to 21 over 16. Now this will not reduce down anymore. There's nothing common that'll go into 21 and into 16. So our answer is done. And then if they wanted us to continue on to do set builder notation or interval notation, graph it, whatever they would ask us to do, we would be able to.